Hi everyone, welcome to my talk. This is Charlie Su, CTO and EVP of AndeSentry Technology. Today, I would like to talk about AndeSentry RISC-V processor IP solutions. I give an overview of our processor lineup and focus on our new offerings. AndeSentry Technology is a 15-year-old pure-play CPU IP public company with headquarters in Hsinchu, Taiwan. We are a RISC-V founding and premium member. We are active in RISC-V International and also a major open source contributor and maintainer. Among the quick facts to update, AndeSentry now has over 6 billion total shipment of AndeSentry embedded SoC since Q3 this year. So where are AndeSentry RISC-V processors used? Here are highlights of recent SoC announcements from our customers. First, Renesas ASSP MCU and also Tailink IoT wireless audio SoC, and both are small but high volume chips. And Picocom used 32N25F to build their 5G small cell SoC. And we have a couple customers using our vector processor and X27V to design their server-grade AI accelerator. They choose AndeSentry V5 processor because of our configurability, capability of custom instruction, safety features, and strong integer and DSP performance, good development tools from AndeSentry, as well as our partners such as IR, and strong LLVM support for AI compilers. Next, let's look at V5 processor lineup. On the left, we have application categories. From bottom to top, embedded control with integrated FPU, and data path processing with DSP or vector extensions, and application processing with single core and multi-core and running Linux. On the bottom, we have processor families from 5-stage 25/7 series and 27 series to 8-stage superscalar 45 series. The core with X in the name are 64-bit, and the core without are 32-bit. On the bottom left corner, we have a tiny core, 2-stage, and 22. The AndeSentry solution for data-intensive computation lie in the DSP extension, vector extension, plus AndeSentry custom extension, while other cores are used in control-intensive environment or a mixture of control and data processing. Today, I'm excited to announce the new member of AndeSentry V5 family, A27L2, AX27L2, A45MP, AX45MP, and also the upgraded vector processor, NX27V. A27L2 and X27L2, from the name, we know that they indicate they are A27 and X27 plus an integrated L2 controller. They support AndeSentry V5 base, just like all AndeSentry cores, which has RV, GCN, and P extension, and MMU support, plus SMO, and V5 extensions. 25 series has a 5-stage single-issue pipeline. It supports programmable PMP and PMA, and its members L1 cache support write skipping, multiple outstanding transactions, and prefetch to deliver higher bandwidth and reduce latency for applications. 27L2's L2 cache controller use 64-byte cache lines with size up to 2 MB, and 16-way set associativity with pseudo-random replacement, and dual bank for tag and data RAM with bank interleavings. To accommodate different types of SRAM, their latencies are programmable. And it also supports MemBoost, and XI bus has both master and slave port, and it supports optional ECC error protections. Compared to X27, X27L2 with a 512 KB L2 cache can achieve 2.1x memory bandwidth and only 30% memory latency, and 1.9 spec int 2000. Next, 45 series. Its base core M45 and NX45 support RVGCN and V5 extensions. On top of that, D45 ASP extension SIMD DSP support. A45, X45, and their MP counterparts include MMU as well. 45 series has an 8-stage in-order dual-issue pipeline. An independent pair of instructions can be dual-issued if at least one of them is an ALU instruction. And most dependent pairs of 2 ALU instructions can be dual-issued too. And its late ALU allows dual-issue of a load and its dependent ALU instruction. This can lead to zero-cycle low-use penalty. Other highlights of the 45 series pipeline include unwrite, data access, supported by hardware, and low-power dynamic branch prediction, and Memboost memory subsystem. 45 series has full memory architecture support. For virtual memory, it has MMU and S-mode, or page sizes, and virtual memory mapping. It has a shared TLB with up to 512 entries. For physical memory support, it has up to 16 entry physical memory protection and physical memory attribute. And L1 IND caches have a size up to 64K with 64-byte lines and up to 4-way SATA associative. It also supports cache locking mechanism to ensure real-time performance. Parity and ECC error protection are optional. And for IND local memory, their size can be up to 16 megabyte and with optional ECC protection. Next, 45MP. It's a cache-coherent multicore. It supports directory-based scheme for scalability and messy coherence protocol. Its coherence manager supports 1 to 4 A45 or AX45, and I/O coherence port for cache-less masters. Its optional L2 cache controller is similar to that of 27L2. And its bus interfaces include memory ports, MMIO ports, local memory slave ports, and coherence slave port. The 45MP complex pre-integrates a PRIC for global interrupt handling and debug module and trace tag support. And Linux SMP is already running. Next, let's look at 45 series performance. Using CoreMark as a reference, 45 series deliver over 5.5 CoreMarks per megahertz, a leading score among the same level of processors. It's about 60% faster compared to the single-issue 27 series. Factoring in the frequency advantage, 45 series delivers 70% higher total performance, with less than 50% increase in logic area and power consumption. So it's a good trade-off for those who need higher performance. 45 series also deliver 35% higher memory bandwidth using memory copy. For those demanding much higher frequency, at 12 nanometer, 45 series can run up to 2.4 gigahertz. So before we talk about NX27, let's take a quick look at Ande's solution for data path acceleration. First, we have RVP DSP SIMD extension, which contain integer fixed point instruction operating on existing integer register. It's suitable for audio, voice, small image, and slow video. And then RISC-V vector extension with scalable vector registers targets high data rate computation, such as large image and fast video. Last, under Andes custom extension framework, Copilot can take user input for instruction extension and automatically generate extended components for tools, ISS, and RTL. In particular, it supports Andes near-cycle accurate simulator for detailed performance analysis and Impera's fast simulator to enable early software development. NX27V, so it was announced in the last summit, and we got a few customer nows. I will talk about more detail and its new features. NX27V consists of a scalar unit and Andes Innovative Vector Processing Unit, or VPU. The scalar unit is based on the core of 27 series with one distinct new feature, FP16 instruction, which allows it to work with VPU for housekeeping AI tasks. In addition, it has even more aggressive memory subsystem to support vector load store, including multiple outstanding on-cache accesses. We have upgraded VPU to support the latest RISC-V spec 1.0. The white green line on the picture indicates the wide load store data path between units. That's from VPU to cache. VPU directly go to the bus for uncached access. And also streaming port, which we will talk about later. NX27V is upgraded to support ELAN 64, so it covers RISC-V standard data format from int8 to int64 and FP16 to FP64. And it also supports Andes extended formats bflow16 and int4 to support diversified AI applications. NX27V has a powerful vector unit for computation speed up. All RISC-V arithmetic instructions are executed there after retired from scaled pipeline. There are multiple functional units operating in parallel and out of order, and they are all chainable, and most are fully pipelined. VPU supports a wide range of VLAN and SIMD width combination from 128 to 512, although most customers like the largest configuration and use multiple of NX27V. VPU needs efficient load store to move data to and from vector register file. For this, it supports two independent memory paths. Besides the standard RISC-V vector load store instruction going through the Y data cache and bus unit, NX27V user can use the AC framework to design vector load store instruction through the streaming port. So what is the ACE streaming port? It is to connect to an external hardware engine and smart memory. It contains a decoupled pair of a command channel and a data channel, both using simple handshaking protocol. The commands are issued by ACE instruction and can be very wide and include custom information. And as an example, the hardware engine can have application-specific DMA to move data to its smart memory and perform structured computation such as CNN operation. And ACE instruction can be used to control hardware engine through the Y command channel and load store data through the Y data channel to and from vector register, as well as other NX27V registers. The code snippet here shows an example of defining a streaming port vector load instruction. The advantage of a streaming port is that hardware engine can be tightly coupled to the ultimate efficiency, and data accesses can be more efficient with additional semantics such as address auto-increment and wrapping around. Here are another powerful usage of ACE for NX27V. RISC-V is very powerful, but it doesn't and cannot satisfy everyone. So we extend ACE to make custom vector instruction possible. Here's the basic idea. You design the instruction with vector operands as input and/or output using the field operands, and specify the input formats of whether they are single width, widening, narrowing, or quad scaling. Then you write CSIM and compact Verilog as the standard ACE way. With this, designer only needs to focus on ELAN level instruction semantics. Taking the design files as inputs, compiler can automatically generate supports for software tools such as compiler, debugger, and simulator, and also automatically generate RTL for decoding, formatting, dependency checking, chaining, and more. And those custom vector instructions behave according to RISC-V control register, such as ELMA, SEW, and VL. So they are RISC-V control aware and work well with the standard RISC-V instructions. NX27V enables a scalable acceleration architecture. At the lowest level, it can be greatly enhanced by ACE and tightly coupled to hardware engine to form a processing unit or a PE for the basis of domain-specific acceleration. At a higher level, multiple PE array can be constructed as a cluster or multiple clusters and share some memory. Separately, the acceleration array can be accompanied with a control subsystem to run control and applications. Separating control from acceleration allows designer to optimize them independently. In the development software side, Andes is working on OpenCL to support such heterogeneous architecture. So if you are interested, we have another talk to cover OpenCL right after my talk. Lastly, I'd like to introduce AndeSentry Security Framework we announced in this summit. AndeSentry is an open framework for a wide spectrum of threat mitigations. It covers from cyber attacks to physical attacks, and it is flexible in choosing a solution for robustness, cost, power, and other metrics. And it is scalable for use from MCU to multi-core. It is trustable because solutions are from Andes and our partners with certified solution and experience. And AndeSentry scope include T, crypto acceleration, and protection against cyber attacks, and countermeasure for physical attacks, and including both hardware and software. And with this, I conclude my talk. So Andes has 6 talks in this summit. So after my talk, Shaozhen will talk about OpenCL support for RISC-V vector extension. And tomorrow, Dinkai will talk about enhancing verification coverage for RISC-V vector extension using RISC-V DV. And Paul will talk about building a secure framework using the enhanced IOPNP. And Changhua will talk about Andes Correctly, a performance bottleneck analyzer for RISC-V vector processors. And the day after, Tan will talk about RISC-V vector extension demystified, which is a 3-hour tutorial. So make sure you don't miss those. Thank you.